This is John Black, Super Chemist. Got the molar weights, times them by how many moles they want, 3, 4, 2, 3, to get what I need. Now I took each of these and divided them by 6 because that's way too much. 600 grams of this, come on. So these are the amounts I got after I divided by 6. This is vodka, so it's 40% alcohol, and so I divided what I needed by 0.4 to get 73 milliliters. So that way I'll use 73, and 29.2 will be alcohol, and the rest should be water. Sulfuric acid, it's probably 95%, so I divided by 0.95. Takes that up to 18.74. And I want to throw a little bit extra in just to make sure it put 20 milliliters. My yield should be 30 milliliters of acetic acid, although since it produces this,
oh, now look at the end here, though. You're making something different. I mean, you're still making the same thing, right? But because of this sulfuric acid, it's going to be in the equation too. Now, instead of this reacting, even if it does, this will just change it back to an acid anyway. So these two are going to react. They're going to make 2 potassium sulfates and 4 waters, plus your original water. The MnO2 you can just filter out. And you're going to be left with 3 acetic acid molecules. You're going to have all acetic acid. It's not going to be a salt anymore. Now the third equation, because I'm taking it from the first equation, and the reason I put 2 sulfuric acid things on there is because look down here at this permanganic acid. Look at the formula. It's HMNO4. So that means I need 1 H for every MnO4. There's 4 MnO4s over there, and 2 times 2 on the H's, so there's 4 H's. In my mind, an acid is an oxidizer, and that's what we're doing. We're making permanganic acid. Because you're going to have 2 protons in solution, and you're going to have 4 protons in solution, and you're going to have 4 MnO4 anions in solution. So isn't that the definition of permanganic acid? So that's how I got the 2 H2SO4 molecules in there. That was my thinking. Now this vodka bottle is what I distilled out of the experiment, and I filtered out MnO2, and this is what I got left. My theoretical yield was 30 milliliters of acetic acid. That's a half a mole. So I weighed up a half a mole, or 42 grams of sodium bicarbonate. I started distilling it at like 104, 105, and then I took it up even higher than that. And the reason why I did that was because I wanted the temperature above water, you know what I mean, above 100 degrees. That way that by the time I got most of it out, that the acetic acid would be included in that water, because I boiled it so much more higher than the boiling point of water. You know what I mean? And then the last 50 milliliters that you leave that are left in the pot, there would be no acetic acid in there. You know what I mean? That's the reason why I distilled it at that temperature. Okay, I want to just do a little pH test. So you can see it's acidic. The pH was a 2. There's barely anything in there. I mean, that's like a 3%. I mean, you can get vinegar for, I think it's 5%, I'm not sure. Like the grocery store. So I'm going to set up, and I'll show you in a second here. Alright, here's my setup. Guys, I'm going to do this off camera, but I'm going to show you at least the first part, so I don't want to screw it up or whatever. As you can see, it reacts. You know what I mean? It's definitely vinegar, that's for sure. And it's, you can go buy this at the store, man, but this doesn't have any sugars in it or any of the additives that they might put into the vinegar, that you buy at the grocery store. Well, I barely have any left. It's still reacting very strongly. I'm going to stir it up and let it all react, and then I'll add some more. Alright, I've been stirring it for a while to get it to stop bubbling. So I don't want it, I want to make sure that it all reacts before I add this little last bit in here. Wow, this is starting to think there's sulfuric acid in here, man. It is still going strong. I barely have any stuff left to throw in here. I'm just guessing, but the first time I threw in, I started out with a pH of 2. The first time I threw in about 20 grams, which is half of what I had, and the pH went up to a 5. I threw in another 10 grams, so that's 3/4 of what I had, and now the pH is up to about a 7. I got about 10 more grams here. I'll throw it in. It's still reacting very vigorously. Oh, that ain't as strong. It's finally dying down. I'm going to have to add a little bit of time. You can see I only have a little bit left though. I mean, there's like nothing there. Alright, we got about a pH of 8 definitely now. I'm just going to dump this last stuff in. I've stirred it up and that, so everything's already reacted. It has slowed down that last addition. There's very little left here, so you can still see it's. I don't know if you can see it on camera. It's still bubbling up a little bit, very slowly, very slowly. See, it is still bubbling, just very slowly. Still smells slightly like vinegar. See all them bubbles? Very little, but they're there. Wow, I am actually impressed. I cannot believe this. I put it all in. I got still got a pH of 8, and still reacting very, very slowly. So I threw in another gram, and it reacted with that. But after that, that was it. So I mean, that little bit, there might have been some in solution that didn't react. I might have added a little bit more alcohol than I thought, or whatever. You know what I mean? A couple milliliters of water. I mean, ethanol. But this is pretty much a 100% conversion, man. I mean, this is wow. I mean, I am wow. I thought that'd be impossible. You know, that's pretty much. This is a good whatever. Gives me more confidence on the aqueous one. Like I said, if you just put the pot on some ice, give it an ice bath, and you know, make the condenser longer, you'll get a lot better yield. But I am so amazed at this. Alright, here's the potassium sulfate I got. It's nice and white. Potassium sulfate is 174 grams per mole. According to the equation, we should have got 2 moles, so I doubled it. Got 348. Now, if you recall, we divided everything by 6 so that we would have lower amounts that we'd have to use for the experiment. So I divided this by 6. I get 58 grams. That means I should have 58 grams here. I have 53. So that's 5 short of what I should have. If I divide 53, divide by 58, it's 91%. So I got a 91% yield on my potassium sulfate. And keep in mind, some of it probably got stuck in the filters, getting the MnO2 out, and some of them I didn't wash. I should have washed them all with water, and I didn't. So there's, you know, probably where the loss came from, because I did not recrystallize this. I just basically evaporated the water off, because I have a whole bunch of this stuff from other experiments. I just want to do them all at the same time.
was actually going to do it with this, but I lost track of time and the water all evaporated before I knew it. So I got a 91% yield on the potassium sulfate. And also this coincides with what I was saying, because my equations at the beginning of the video, that's just a guess. But it does seem like it is right. You know what I mean?
Now here's my manganese dioxide, MnO2. I got a pen here, regular size, standard big pen, so you can see the size of it. I'm going to take that and put it in a big jar. And here it is in a big jar. I found this jar. I don't even know where this came from. But it's like a gallon. Here's a gallon next to it. Give you a little comparison. Now you can tell it's an old jar. How, you know, it looks like an industrial jar, like a restaurant hat or something. But it's a gallon glass jar. You know what I mean? Those are hard to come by. So I put it in there, and I'm going to wait until I have all my experiments done with potassium permanganate, or at least until I get this jar halfway filled up, or at least a third of the way or something. Because, you know, you're going to lose a lot into the filter and stuff like that, and it gets a fine precip into the water when you clean it. Basically, I'm going to put this stir bar in, which I found it too. I moved the dresser out, or desk, or whatever you call it, in the kitchen, and there it was underneath. I found one. I started out with 7 stir bars. A good tip is, because this is how I lose them most of the time, is I filter them out, and then I forget them, you know what I mean? I throw the filter out, probably because like when I'm doing it over and over, and I can't get the crap out, you know, it gets you frustrated. And then you end up throwing your stir bars out in your filter paper. But anyways, I found this one, so I'll put this in there, and I'll fill this all the way up with water. I'll spin it, first I'll stir it, you know what I mean, after I get the water in there, and let it mix up. I'll let it settle down. I will decant off the water, and then I'll use distilled water the next time, and I'll do it again. But this next time, I'll decant it out, and then I will get the rest of the stuff out and put it in a vacuum filter so that I can, you know, a Frit filter, and put a vacuum on it, get it nice and dry, and then I'll put some more distilled water on it and suck it through again, get it nice and dry, and then I'll throw it on a plate to dry it, and I'll have nice pure MnO2. You can see I got the MnO2 on the glass and in the container itself. Let's pour some hydrochloric acid on it. See how I took that away? It's all clear now. It's that simple. That's how you clean all your stuff. Just swirl it around and it'll go away in a second or two. I poured a whole bunch of extra water in there because I couldn't get the ridges. It wasn't hitting the ridges. But you can see how white it got everything. It's crystal clear. But just to let you know, MnO2, this is the molar weight or molar mass, whatever you want to call it, 87 grams per mole. The equation called for 4 moles, so I multiplied it by 4. And then remember, we divided by 6 for everything. So I divided by 6. I should have 58 grams for the reaction, but you know, that stuff sticks into the filters. You know what I mean? You might end up with only 48 grams or 40 grams. Like I said, I'm going to do mine all at once, so I don't really know. Anyways, you all have a great day, and always remember, science is great.